Welcome to this lecture. In the last couple of lectures, we have been discussing about the white box testing, and we had said that white box testing has to be carried out on a unit, even though we are also performing black box testing. And we had said that there are several types of white box test strategies, and we had discussed about statement coverage based testing and then the branch coverage based testing. If you remember, it said that branch coverage is a stronger form of testing. If we are doing branch coverage testing, then we need not do the statement coverage testing. But is branch coverage testing good enough, or in other words, are there stronger testing strategies which we need to carry out, and if we carry out those, branch or decision testing becomes not necessary. Let us see the other types of testing. In the last few lectures, we discussed about statement coverage based testing, and then we had discussed about branch coverage testing, which is also popularly known as the decision coverage testing. Now, we will look at the basic condition coverage testing, and we will later, after basic coverage condition testing, we will look at the condition decision coverage based testing, and then we will look at the multiple condition coverage testing, MCDC coverage testing, path coverage testing, and then the data flow coverage testing, and finally, the mutation testing. First, let us address the question that is the branch coverage testing good enough, or to tell that in other words, if all branches have been tested, can we miss some specific test conditions, or can bugs remain even after we have completed branch coverage testing or decision coverage testing. Let us take a simple example. Let us assume that we have a conditional statement, if C is equal to alphabet or C is equal to digit, where C is a variable, character variable, and we have read C from the keyboard, and then we are checking here if C is either an alphabet or C is a digit, we are doing some special processing for that. Maybe we are recovering the integer value of C. If it is a digit, we will C is equal to C minus A, let us say, which will retrieve the integer value. But then if we are doing the branch testing, we need to have the branch condition assume true and false values. To make it true, if we have C is alphabet, that is capital A to capital Z and small a to small z, then if it becomes true, this condition does not matter, because this is a OR condition. Any one of that becoming true will make the branch condition true. Now, let us say that the second test case is a special character, like a control character or something. So, now the expression, when we evaluate, C is not alphabet and C is not a digit, because it is a special character, and therefore, it becomes false. But the fault is when C is equal to digit, we are not doing it properly. Let us say we have made it c is equal to c minus small a. So, I made a small mistake here. To get the integer value, we made a small mistake, but then our two test cases, that is c is a alphabet and c is a special character, achieves decision coverage, and the faulty sub expression which is c equal to digit, that is not tested, and the bug remains even if we are achieving decision coverage, testing both the outcomes of the branch condition, but still we are not able to detect the bug, and that the reason for that is that we are not considering this sub expression becoming true any time. If we had a test case which not only turns the first sub expression true and false, we also should have test cases making the second sub expression true and false, and in that case we could have detected the bug. So, that gives us a hint that we should look at the sub expressions and we should ensure that the test case makes each sub expression assume true and false values, and exactly based on that idea the basic condition coverage testing is designed. Let us look at the basic condition coverage testing. In the basic condition coverage testing, for a branch condition having multiple clauses, which we will call as the complex condition, each of the sub expressions or the clauses will require them to achieve true and false values. And you can see that if we make that, then the bug which was earlier not getting caught will get caught. But then is it a good testing? Is it, first of all, is it stronger than the statement coverage? Is this kind of testing, the basic condition coverage testing, is it stronger than simple decision coverage testing? Let us try to answer those questions, and is it a good testing strategy? Let us try to answer those questions. First, let us see how do we design the basic condition testing strategies. Let us take a example conditional expression if a is equal to 10 and b is less than 50, and our objective is that each of the sub expressions will achieve true and false values. Now, to make a is greater than 10, to make it true, we will make a is 15, and to make b is less than 30, we will assign some value b is equal to 30 or something like that. And therefore, our first test case is a is 15, b is equal to 30. So, this is the test case 1, which will make the two sub expressions true. Now, we need another test case which will make both the sub expressions false. So, let us choose a is equal to 5, 5 is less than 10 and therefore, this is false, and let us say b is 60, 60 is greater than 50 and therefore, the second sub expression is also false. So, these two test cases will achieve the simple condition testing or the basic condition testing, where each sub expression is made into true and false values. But can we always perform basic condition testing? Yes, we can perform basic condition testing, and if the two sub expressions are independent. If there is a dependency between these, we may or may not achieve basic condition testing. Let us say A is greater than 10 and A is less than 5. That we cannot. For that condition, there is a dependency between two sub expressions and becomes difficult to design the test case. It cannot be at the same time greater than 10 and A is less than 5. But if we have independent clauses, we should be able to design basic condition testing, and how many test cases would be needed? In one test case, we can assign true to all, and another test case we can assign false to all. So, two test cases should be good enough to achieve basic condition testing. But how does this testing compare with the branch coverage and the statement coverage testing? Let us try to examine that. Okay, there is another example before we check how effective it is. There is one more example. Let us say we have C1 and C2 or C3. So, there are 3 clauses here and 3 sub expressions or clauses, and we will make each one of these true and false. Even though there may be 3, 4, 5 whatever, if they are independent, then we can design test cases such that all are true and all are false. So, each sub expression gets true and false values. So, basic condition coverage is satisfied, but we just use 2 test cases. Now, if we use some test cases to test a branch condition, what is the percentage of coverage achieved? Let us define a metric which we call as the BCC metric, basic condition coverage metric, and here we have this simple expression: the number of truth values, that is true and false, taken by all basic conditions, and 2 into number of basic conditions. So, if we have a expression like A is equal to 10 or B greater than 5 and C less than 100, we can see here that there are 3 atomic conditions or the basic conditions, and the possible outcomes of each of these is 2 into 3. So, that is 6. Now, let us say we designed a test case which made this true, false, false. The second test case made true, true, false. So, this is the first test case outcome, this is the second test case, and using 2 test cases we achieved this coverage of the basic conditions. And then what is the percentage coverage achieved? So, we achieved true, false, false and also true value for the second condition. So, we have achieved 4 of the decisions out of the 6. So, the coverage will be 2 by 3. but is it a strong enough testing? How does it compare with the decision coverage and statement coverage? Let us take an example. If a greater than 5 and b less than 3 or c equal to 0, and then we have some action here, a is equal to 10, and we can use two test cases to achieve basic condition coverage. Let us say a is equal to 10, this is true, b is equal to 2, this is true, and c is equal to 2, this is false. So, the first test case achieves true, true and false. The second test case, a is equal to 1, which is false, b is equal to 10, which is false, and c equal to 0, which is true. Now, we have achieved basic condition coverage using these two test cases. So, each of the sub expressions achieves both true and false values. But then let us see if decision coverage is obtained. True and true. So, this clause will become true, and irrespective of this, even though it is false. So, the branch outcome will be true. Now, let us see the second one, false and false. So, the clause here will become false, but then the second sub expression becomes true. So, the outcome is again true. So, even though the two test cases are able to achieve basic condition coverage, but they are not able to achieve the decision coverage. From this we can conclude that even though basic condition coverage may be satisfied, but still decision coverage may not be obtained. Or in other words, we cannot say that basic condition coverage is a stronger form of testing than decision testing. But is decision coverage testing stronger than the basic condition coverage? No, that is also not true, because we had already seen that basic even though the decision coverage was achieved for c is equal to alphabet or c is equal to digit, we could achieve the decision coverage, but that did not achieve the basic condition coverage. We can therefore say that the basic condition coverage and decision coverage, these are complementary, they are not really comparable testings. One cannot really is stronger than the other testing. Now, let us see the condition decision coverage testing. But let me just pose another question to you, that the basic condition coverage testing and the branch coverage testing, these two are not really comparable. You can't say that any of these two is stronger than the other. But what about the statement coverage testing? We know that branch coverage testing is stronger than statement coverage testing. But what about the basic condition coverage and the statement testing? Can we say that basic condition coverage is stronger than statement coverage testing, or is it vice versa, that statement coverage testing is stronger than basic coverage testing? Of course, from common sense we can say that statement coverage testing cannot be stronger than basic condition coverage testing, because one which is stronger than the statement coverage, that also is not stronger than basic condition testing. But what about this basic condition coverage? Does it achieve statement coverage? Please try to reason it out, give examples or prove what is the relation between basic condition coverage and statement coverage testing. But our idea while discussing about the branch coverage testing was to come up with a test strategy which is stronger than branch coverage testing, but at the same time achieves condition coverage, and basic condition coverage could not do that. Can we impose the condition that we should achieve the basic condition coverage and also the decision coverage? So, that is the strategy that we will discuss now. It is called as condition decision coverage. The condition decision coverage strategy, here we achieve basic condition coverage and also the decision coverage, and here each of the atomic condition is made to assume true and false values. That is, the basic condition coverage is achieved, and also the decision as a whole is also made to achieve true and false values. So, you need test cases for those, and therefore, this is a stronger testing than the basic condition testing or the branch coverage testing, because it achieves both of these. But is it the strongest testing? You can see that this is stronger than both branch testing and the basic condition coverage, but is it the strongest? No, the strongest is multiple condition coverage. Here all possible atomic conditions, the atomic conditions are made to assume all possible combinations of truth values. If we have, if A greater than 5 or B less than 20, in that case our test cases should make this true, this false, this true, false true and false false. In general, if we have n sub expressions or clauses in a complex decision statement, then we will need 2 to the power n test cases to achieve the multiple condition coverage. So, the multiple condition coverage testing should ensure that all the sub expressions, they achieve all possible combinations of truth values. Now, let us look at an example. If we have this example A or B and C, we have 3 sub expressions, 3 Boolean values, and if we need to achieve the multiple condition coverage, how many test cases do we need? We need 2 to the power 3 test cases, which is 8. Let us see what will be the test cases. A, B, C, these are the 3 sub expressions or Boolean variables, and then all possible combinations of the truth outcomes of these 3 sub expressions or Boolean variables, true, 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 false, and so on. And there are 2 to the power 3 2 to the power 3 is 8 test cases are needed. We can say that to achieve the multiple condition coverage, the number of test cases is required is exponential in the number of the sub expressions or the basic atomic conditions. But then this can be huge, because in many applications, especially in the controller, embedded control applications, in user interfaces, etc., it is quite common to have expressions involving 10 or 20 sub expressions, and if you have 20 sub expressions in expression in a decision statement, we will need 2 to the power 20 test cases, or which is a million test case. Just imagine that just to test one branch we need a million test cases to achieve multiple condition coverage, but if a unit has 10 of that, the number of test cases will be enormous. Even million is a large number. A tester would have to spend a couple of years to run the million test cases. We can therefore say that the multiple condition coverage is a strong form of testing when there are branches, but then it is impractical, because it requires too many test cases when we have multiple clauses or multiple sub expressions, 10 or more, or even 8, 7, these also lead to large number of test cases. So, can we have a compromise, a test strategy which will achieve as thorough testing as the multiple condition coverage, but then the number of test cases should be few. For expression it should be 3, 4, 5, something like that, it should not be thousands. Now, we are almost at the end of the lecture. Let us stop here and we will continue from here in the next class. Thank you.